So it's a Tuesday morning and I'm just walking into Dr. Priver's office. It's a sunny day here in Kampala and we are at the National Agricultural Research Organization. Dr. Priver, good morning.
Good morning to you, Halima.
How are you doing?
That's reporter Halima Athumani on her way to talk with Dr. Priver Namanya Bwesigye for this week's episode of Africa Science Focus.
I am a team leader here at NARO for the National Banana Research Organization. We do banana research from basic science, genetics, agronomy, breeding, biotech. We engage with farmers. So people call us plant biotechnologists, maybe plant engineers.
Bananas are an everyday part of life in Sub-Saharan Africa. We eat them at breakfast and lunch and cook them as part of our evening meals. We roast them, fry and dry them, and ferment them to make juice, beer, wine, and even gin. Uganda is among the top 10 banana-producing countries in the world and is home to the much-loved matoke banana, also known as the East African highland banana. But the matoke, along with many of the other banana varieties that are native to Sub-Saharan Africa, is under threat from diseases and pests. I'm Michael Kaloki, and on this week's show, we meet banana researcher Priver Namanya Bwesigye, who is a specialist in both conventional plant breeding and biotechnology, and is one of the continent's leading female bioscientists.
You just called yourself a plant engineer, and I think your main focus here is bananas. Someone would say, Uganda is naturally gifted. We've got so many bananas. Do we need to study that much about bananas?
Yes, of course. Yes, of course. These crops get challenges, they interact with the environment. So there are diseases and pests that affect these crops. So we need to study them to know how to manage them, to support the farming communities, both for production but also for trade and use. Yeah, we study them. Yes, we study them.
In Uganda alone, there are 120 East African highland banana varieties, which are not found anywhere else in the world, according to the International Institute of Tropical Agriculture, which is based in Nigeria. But growing bananas is not easy. The plants need a lot of water, around 4 times the amount that beans and pea crops need, and Uganda's bananas are struggling with diseases. Black sigatoka disease causes fungus to grow on the banana leaves, and the fruit becomes ripe too quickly. Half of a banana crop can be lost to this disease. Banana xanthomonas wilt was first found in Ethiopia in the 1970s and has spread from Uganda across the Great Lakes region over the past 20 years. And Fusarium wilt, another fungal disease, has spread worldwide and is now a serious threat to banana production. This is where Dr. Namanya's research comes in. She tells us why Uganda's bananas and the vital nutrition that they provide need protection.
In your studies, trials for a banana variety which is resistant to wilt and contains vitamin A have been ongoing since 2004 in an effort to improve production. Talk to us about that.
The bananas naturally have vitamin A in them, but it is low. But because we eat bananas every day as a staple crop and with minimal supplementation or dietary diversification, we have, as a country, a huge population of children and youth that have vitamin A deficiencies in critical minerals or nutrients handled maybe by food fortification. Communities that depend on diet on staple crops really do limited diversification, but also limited food supplementation, the blue bands and the cereals and, those things which are fortified. We looked at biotechnology as an opportunity for improving the staple food crop for vitamin A. It comes in, there's a beta carotene. You see the yellow that is in carrots, the yellow that is in purples. That's where we get vitamin A from, or in green vegetables. So we are able to use biotechnology means to get the building blocks that allow vitamin A in those varieties to be high. We introduced them into our local variety so that when we eat our local variety, we are able to get at least 50% of the vitamin A that we need as a daily requirement. It helps us to build our immunity, the immunity of our bodies. So children who are low vitamin A levels in their bodies, they are prone to die from simple diseases like malaria and simple infections. But when the vitamin A levels are good in their bodies, their immunity is better.
Dr. Namanya's team at the Banana Research Program have established systems for the genetic engineering of bananas and carried out confined field trials, though the bananas are not yet available for commercial use. But she says that genetic engineering is not a magic cure for Africa's farming and food security challenges.
When people talk about biotechnology, there's a tendency to talk about genetic engineering. But genetic engineering is just one tool, just one method of biotechnology. For example, tissue culture, the method that we use to multiply clean planting material without adding anything is biotechnology. There's old methods of biotechnology like fermentation. Fermentation is biotechnology. There are very many applications of biotechnology, both in agriculture, in medicine, in animal health, and they're wide broad. So genetic engineering is just one method. Say, Halima, genetic engineering does not fix everything. There's a lot more that we need to do. Okay. It's not a bullet that is going to fix everything. Mm-hmm. When you talk about drought, for example, we get a lot of rain. We don't harvest the water. We would be able to irrigate if we were harvesting the water. So is harvesting water going to be fixed by genetic engineering? No. There's a lot more that we need to do to change our methods of cultivation, to move to mechanization, to move away from peasantry.
If you could just take a sneak peek on what are some of the things that we need to do to fix our farming, our food basket.
Let's start from the farmer level. You have peasant farmers, small-scale farmers, strengthening their ability to produce together, strengthening their ability to access inputs, strengthening their ability to market together, strengthening their ability for post-harvest quality, the consistency of productivity. You have a bumper harvest, and all of a sudden there's nothing because there's no system for storage, there's no system for post-harvest management, there's no functional system for marketing, value addition. So if we had harvested water, as just one example, and we're able to irrigate, we would have vegetables throughout the whole year.
Dr. Namanya was recognized as a breakthrough young researcher by the Association for Strengthening Agricultural Research in Eastern and Central Africa. But her career hasn't always been easy. Here, at a Science Stories Africa event, Dr. Namanya spoke openly about how close she came to giving up on her research entirely.
I was with a team of 3 Ugandans. We were in the lab working almost late into the night. We had a lab full of experiments and petri dishes and days under the microscope. For us to use the technologies in biotechnology, we would need to reduce the banana plant to its bodybuilding blocks, which we call cells. And we would have to show that we can regrow the plant from the cells. Now that was the problem. So we worked 1 year, 2 years, and 3 years down the road. I tell you what, the banana plant had refused. We were running out of time. The pressure was getting too high. Accountability for money, for a product, for a system in place. And I was the team leader, I was the lead scientist for the team. And so my team leader called me to his office and threw the challenge into my face. I had been registered at Makerere University for a master's degree. I was beginning to panic. I knew I had to deliver. But I felt like, this is not giving me what I am looking for. I ran and I got myself another job. I passed the interview, but the director of the organization called and said he wanted to speak to me particularly. So I sat in his office and he looked at me and said, Priver, you are a clever girl. You have invested so much in what you have been doing. You are our best candidate, but we are not giving you the job. And he bluntly told me, go back to Kawanda. You have a career there. We don't have a career for you here.
More girls and young women could be encouraged to follow in her career footsteps if they are supported and guided through their studies. Dr. Namanya tells Halima.
We are told we are in the generations before, even girls were never sent to school. So that still runs in the blood of the society. And in some homes, boys are sent to school and girls stay home. And in some societies, they'll tell you, why do you send a girl to school? After all, she's going to get married. It's as if you don't need to learn to be a mother, because a mother is the first teacher of generations. So teachers mentoring girls, parents mentoring girls, communities standing up for girls. But also, more girls just need to be mentored, spoken into their lives, help them to find themselves, being self-aware. I was aware of myself and I picked up my confidence and I knew that I could be anything. If men would believe in their daughters, if men would defend their daughters, if men would adore their daughters. I lost my father last year in December. My father was my mentor. He believed in me. He encouraged me. He asked me questions. He wanted to know how was I planning to progress. But if fathers look at daughters as a source of income, temporary income, as a property to sell, it is sad. Those types of men do not deserve to have children.
You can find out more about Dr. Priver Namanya Bwesigye's career by visiting www.scidev.net. That's www.scidev.net. You can catch up on all Africa Science Focus episodes on your favorite podcast app. And don't forget to leave a review. Today's program was produced by Harrison Lewis and edited by Fiona Broom, with reporting from Halima Athumani. Africa Science Focus is produced by SciDevNet and distributed in association with your local radio station. I'm Michael Kaloki. See you again next week. This program was funded by the Carnegie Corporation of New York.